Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the chapter that is isomerism in hydrocarbon. In isomerism hydrocarbon, this is part 6 where I am going to explain isomerism alkyne with examples. And before that, part 1 to part 5 where I have explained isomerism in alkane and alkene with different important examples. Now you can see isomerism of alkyne with examples. So please, it is one request to you all. When you read this chapter, this topic, please read first part 1 to part 5, then come to part 6. Anyhow, again I am going to explain shortly what is isomerism and different type of isomerism we can check here. Now, isomerism means same molecular formula but different arrangement atoms. That means when you see the formula same but different arrangement of atoms there and with different physical and chemical properties. When you see physical property that is different, when you see chemical properties that is also different, and this is called isomerism. Now, when you come to isomerism, and that phenomenon is isomerism, and the compound which are undergoing the process of isomerism, that is called isomers. Are you clear? Isomers means the compound which shows isomerism, and the phenomenon, the process is called isomerism. Now, first is structural isomerism, very important. One is structural isomerism, and second one very important, that is stereoisomerism. Structural isomerism, that means where some same molecular formula but different structures. When you see the structures are different, when you count the number of carbon and hydrogen atoms in the molecule, that is same. That means same molecular formula but different arrangement, different structures are there, and then it is called structural isomerism. Structural isomerism are different types. One is chain isomerism, position product, the compound is isomers, and process isomerism. So if the products, the compounds are different in chain isomerism, isomers. So the process, that phenomenon is isomerism. You can say chain isomerism, position isomerism, functional isomerism, then metamerism, tautomerism, ring chain isomerism. Then what is the mean? Already I have explained in part 1, up to part 5 also. Again I want to explain shortly. First is chain isomerism. What is chain isomerism? Chain isomerism means the branch one different. Same molecular formula but the branch position that is different. I will explain one by one. Then position isomerism, position of functional group, position of double bond, position of triple bond, position of OH, CHO, like this. If the position is different, 1, 2, 3 like this, then it is called positional isomerism. Functional isomerism, functional means functional group. If it is 1H, OH, if it is CHO, you will check keto group. If it is alcohol group, if it is keto group, then, but you find the molecular formula remains same, and also you can find here structures are different with the different functional group, that is called functional isomers, and the phenomenon functional isomerism. Metamerism, if the alkyl groups are different, suppose this is the functional group where this side and this is alkyl and this is also alkyl, and both are different groups. Suppose here ethyl, here methyl, here propyl, here ethyl, like this, that is different, but here the molecular formula remains same, and that is called metamerism. Tautomerism means the equilibrium position, equilibrium between the both sides, that is if different, then you can say enolic form, then keto form, CO, enolic form, then here you can see there the tautomerism means the equilibrium between these two groups that is existing, then it is called tautomerism. Then come to ring chain isomer, ring chain. See here, chain structural isomerism, where you can see in ring form. Ring form means cycloalkane, alkene like this. and you see the actual it is alkene alkyne. Now here in this chapter alkyne, you will see alkyne, the ring chain that should come to cycloalkene. Now we will come to here one by one, chain isomers, position, functional, metamerism, tautomerism, then come to ring chain isomers. Now we will start chain isomerism and the compounds that undergoes chain isomerism, that is called chain isomers. Now see one by one. Now you will come to point isomerism in alkyne, that is triple bond. Here you will see what are the possible isomerism in alkyne. So many isomerisms are there, but they are all are not following by that alkyne group. So that is why first you will see position isomers, that means position of triple bond where it is called but1 it is called but2, that means after 1 there is a triple bond, after 2 there is a triple bond. Check it, 1 2 3 4 3 1 4 2 2 4 3 1 4, that means all the carbon has satisfied its balancing, and but1 because after 1 there is a triple bond and after 2 there is a triple bond. So it is called but2, it is called but1 because since after 1 after 2 the triple bond is there, so you can say this is position isomerism because here it is 2 position and here it is 1 position and triple bond is there. Then come to functional isomerism, that is so not very important or very great thing for the alkyne, but anyhow it follows some points. Here see but1, that means triple bond is there, this is the triple bond. And now but1 and where you see buta-1,3-diene. Diene means di 2 times double bond. Here you can say 1 2 3 4. That means in one position after 1 there is a double bond, after 3 there is a double bond, and total carbon 4. So it is buta-1,3-diene. What is the name? Buta-1,3-diene. Then here also you can see after 1 there is a double bond and after 2 there is a double bond. So name is 1,2-diene. Check it, 2 2 4 2 2 4 or 2 3 4 3 1 4. That means carbon are satisfied by its balancing. Now buta-1,2-diene. After 1 there is a double bond, after 2 there is a double bond. That means alkyne here, this is the triple bond functional groups, double bond functional group, here also it is double bond functional group. Then you will see ring chain isomerism and simply chain isomerism. Then come to ring chain isomerism. That means it forms one ring, and here you will see what is the type of isomerism possible, that is called cycloalkene. That means if you say alkyne, it produces the ring chain isomerism, that is cyclopropene. If it is propyne, propene. If it is butane, cyclobutene, like this. See propyne, now it is form as cyclic form, chain it is chain form and it is cyclic ring form. So it is cyclopropene. You can write like this or you can write like this. And now you can check 2 1 3 4 3 1 4, that means it is correct ring chain isomerism. Then come to simply chain isomerism. Simple chain isomerism is not possible for all, and first you can see it is possible for pentyne, pent1, and here 3-methyl-1-butene. That means here what happens, here one CH3 group as a function, as a substance it is present, but here you can see there is no substance present. You can see whether it finds rule or not, it is pent1 is or not. If it is not correct, that is not possible at all. So 314 and here 314 and 234 234 31. That means carbon has 4 valency, it is satisfied, it is pent1, and it is 1 2 3 4. In 3 position there is a methyl group, after 1 there is a triple bond. So what is the name? 3-methyl-1-butene. That means in after 1 there is a triple bond, 1 butane. In 3 there is a methyl group, 3 methyl. So you can find here these both are correct. Both are having same molecular formula where chains are different. Here there is no substituent group and here one substituent group, and that is called pent 1 wine, where it is called 3 methyl 1 butane. So it is fully correct. So this is called chain isomerism, where you can't see here in butane, because if you write the butane you can't proceed that any alkyl group. Either see examples of butane. Now you can say this is position but 1 wine, but 2 wine, but 1 wine. After 1 there is a triple bond. But how many carbon? 4 carbon. So it is but 1 wine. And what is that one? But 2 wine. That is position isomerism, because here the position of triple bond is different. Here 1 position, here it is 2 position. So if the position of it is 1 2 3, so sorry, it is 3, because see I can check here, since I have written 2 2 1 3, valency of carbon is not satisfied, so easily I can find it is wrong. That is why again I have checked, and here I have written 3 3 1 4 3 1 4 3 1 4 3 1 4. That means here carbon valency 4, it is correct. So but 2 wine, but 1 wine. So these are called, these both are called that they follow position isomerism. Next we will see what are the different compounds and how they follow, or what type of isomerism. Then see other isomerism of butane. Now see, it is but 1 wine and it is ring chain form, that is cyclobutene. Here it is cyclobutene means 4 carbon, see, and here double bond, so cyclobutene. And you can find here they have same molecular formula but different arrangement of atoms in ring chain form. That is why it is called ring chain isomerism. So it is cyclobutene and it is but 1 wine. Then examples are pentine. You can see it is pent 1 wine, after 1 there is a triple bond, and it is pent 2 wine, after 2 there is a triple bond. That is why it is called position isomerism, which shown by pentine, that is pent 1 wine, pent 2 wine, after 1 there is a triple bond, after 2 there is a triple bond. So I hope it is clear. That is called position isomerism, position of triple bond different, one is 1, second is 2. Next is, that is called chain isomerism. Chain isomerism means here some substituent groups should be there in other one, whereas the simple one is pent 1 wine. You can find here there is no substituent group, and that is why 1 2 3 4 5. So this is, you can see it is 2 methyl but 1 wine. There is no change in bond, triple bond after 1, triple bond after 1 carbon, but here only 1 2 3 position there is a methyl group which act as a substituent group. So it is called 3 methyl but 1 wine. Are you clear? 3 methyl but 4 carbon, after 1 there is a triple bond, but 1 wine. And you can see here it shows also ring chain isomerism. Ring chain means pent 1 wine. That means here 5 carbon atoms are there and 1 triple bond is there. Now this changes to a double bond, and it is pent 1 wine, and it is cyclopentene. You should write name cyclopentene. That means it is in the form of a ring structure, and here one double bond is there, and the name is cyclobutene. Here it is cyclopentene. Pent means 5 carbon, in means 1 double bond, and cyclo means ring structure, closed structure. So it follows ring chain isomerism. Again you check butane also form another one, that is ring chain isomerism. One simply but 1 wine, cyclobutene. And examples are pentine, 1 pentine, 2 pentine. That is called position isomerism, because after 1 there is a triple bond, after 2 there is a triple bond. Then come to pent 1,1. It shows 3-methyl-but-1,1, which is chain isomerism. Then come to here, that is ring chain isomerism, where it forms ring, and that is cycloalkene, that is cyclopentane, and that is ring chain isomerism. I hope it is clear to you what are the type of isomerism possible in alkyne, especially butane and pentane and also propyne. And I hope you will subscribe my channel, and that is BL Das, short and sweet in chemistry. Thanks for watching my video. Again, thanks to all.